Hello everyone, this is the fifth unit of refrigeration and air conditioning systems. In fifth unit we have different components and some of the types of air conditioning systems. Basics of heat pump and heat recovery. A heat pump extracts heat from a heat source and rejects heat to air or water at a higher temperature. Especially, we use heat pumps in cold areas where the temperature, atmospheric temperature, is very less than the human comfort temperature. In those areas, heat pumps are used in order to maintain the room temperature equal to the human comfort temperature. A heat pump, that is why a heat pumps are used. Here, the desired effect of a heat pump is heat rejection, whereas the desired effect in a refrigeration is heat addition at the evaporator, and here it is heat rejection to high temperature, we call it as source. During summer, the heat extraction or refrigeration effect is the useful effect for cooling, whereas in winter the rejected heat alone or rejected heat plus the supplementary heating from a heater forms the useful effect for heating. A heat pump is a packaged air conditioner or a packaged unit with a reversing valve or other changeover setup. A heat pump has all the main components of an air conditioner or packaged unit like fan, filters, compressor, evaporator, condenser, short capillary tube, and controls. Just like in refrigerator components, the heat pump components are also same, but the desired effect is drawn at condenser, not at evaporator. And the COP, coefficient of performance, is given by for a ideal heat pump. COP is equals to TH by TH minus TL, and we also know that COP of a heat pump is equals to 1 plus COP of a refrigerator. Now, basics of heat pump and heat recovery. The apparatus for changing from cooling or heating or vice versa is often a reversing valve in which the refrigerant flow to the condenser is changed to the evaporator. Alternatively, air passage through the evaporator may be changed over to passage through the condenser. A supplementary heater is often provided when the heat pump capacity does not meet the required output during low outdoor temperatures. A heat pump system consists of heat pumps and piping work. System components include heat exchangers, heat source, heat sink, and controllers to provide effective and energy efficient heating and cooling operations. Heating is required in cold areas, cooling is required in hot areas. So a heat pump system consists of heat pumps, piping work. System components include heat exchangers. Heat exchangers means like evaporator and condenser. Heat source. Heat source, heat sink are also evaporate. Source is the place where it extracts heat. Sink means the place where it rejects the heat. And controls to provide effective and energy efficient heating and cooling operations. Heat pump cycle, pH graph. Uh, the curves are saturation curves, and 1 to 2 is compression, 2 to 3 is condensation. In 2 to 3 the heat will be rejected. That is what is our desired effect actually. For refrigerator the COP is Q124 by work input, whereas for a heat pump the COP is Q223 divided by work input, and 3 to 4 as it is the constant enthalpy isenthalpic process, and 4 to 1 is heat addition, that is at constant pressure, uh, that takes place in evaporator. That's why 1 2 3 4 and 1 is a cyclic process, where 3 to 4 is an isenthalpic irreversible process. Here polytropic compression is a real and irreversible process. Both the subcooling of the liquid refrigerant in the condenser and the superheating of the vapor refrigerant after the evaporator increase the useful heating effect Q2 to 3. Excessive superheating, which must be avoided, leads to a too high hot gas discharge temperature and to a lower refrigeration capacity in the evaporator. Classification of heat pumps according to the types of heat sources from which heat is absorbed by the refrigerant. Currently used heat pump systems can be mainly classified into two categories: air source and water source heat pump systems. Water source heat pumps can be divided into water source, groundwater, coupled, and surface water heat pump systems. Heat pump systems are often energy efficient cooling heating systems. Many new technologies currently being developed, such as engine driven heat pumps, may significantly increase the system performance factor of the heat pump system. Ground coupled heat pumps with direct expansion ground coils provide another opportunity to increase the COP of heat pump system. Groundwater heat pump systems. Groundwater heat pump GWHP systems use well water as a heat source during heating and as a heat sink during cooling. When the groundwater is more than 30 feet, mean 9 meters deep, its year-round temperature is fairly constant. Groundwater heat pump systems are usually open loop systems. They are mainly used in low rise residences in northern climates such as New York or North Dakota. Sometimes they are used for low rise commercial buildings where groundwater is readily available and local codes permit such usage. A typical groundwater heat pump system, and it is shown in the figure. You have a heat pump here, interior zone supply air. Summer it is 68 Fahrenheit, winter 48 Fahrenheit. and 142 GPM, summer 58, winter 46. Discharge to river, chilled water return, and you have a condenser, you have groundwater, evaporator, compressors. So all these clubbed together to produce a heat pump. A typical residential groundwater heat pump system. You have recharge well, recharge pipe, multi-stage propeller pump, motor, supply well, pre-cooler, WSHP, and air in. Ground coupled and surface water heat pump systems. Ground coupled heat pump systems can be categorized as ground coil heat pump systems and direct expansion ground coupled heat pump systems. Of the ground coil heat pump systems, both horizontal and vertical coils are used. Many types of direct expansion ground coupled heat pump systems are still being developed. In fact, horizontal ground coil heat pump systems are the most widely used ground coupled heat pump systems. Ground coupled and surface water heat pump systems, air to air heat recovery, and that is in HVAC. And we need to discuss about the fans, types of fans, air filtration, filters, filter types. The air to air heat recovery. In HVAC and refrigeration, air conditioning and refrigeration, heating, ventilation, and air conditioning and refrigeration systems, it is always beneficial if the cooling effect of the exhaust air can be caused to cool and dehumidify the incoming outdoor air during summer. And if the heating effect can be used to heat the cool outdoor air during winter. Air to air heat recovery is used to recover the cooling and heating energy from the exhaust air for the sake of saving energy. In an air to air heat recovery system, the exhaust air is the airstream used to provide cooling capacity or heating energy to the other airstream used to extract heat energy from or release heat energy to the exhaust airstream is the outdoor airstream, which has a greater temperature and enthalpy difference between these airstreams than the supply airstreams. Ground coupled and surface water heat pump system. Here in this figure we have ground coil. It is S-type ground coil, and water circulating pump, water source heat pump, air out, air in. Now we need to discuss about fan fundamentals. Fan is also required for blowing the air. A fan is a prime mover of an air system or ventilation system. It moves the air and provides continuous airflow so that the conditioned air, space air, exhaust air, or outdoor air can be transported from one location to another through air ducts or other air passages. A blower is usually an enclosed multi-blade rotor that compresses air to a higher discharge pressure, and we will discuss this fan fundamentals in the next video, and we will continue later in the second part. So far whatever we discussed is the heat pump and its importance. In colder areas the heat pumps has much importance, and it is required to be implemented in different areas for air conditioning purpose.